These are the steps which are followed, starting with the checking of the left turn, then the lane groups, then saturation flow rate, V bias ratio, then phasing plan, yellow and all red time, lost time per phase and the cycle, selection of volume capacity ratio design, and cycle length, then effective green, then dividing the effective green, then calculating the actual green, and then the pedestrian check. Today, as I said, we start with an example. This is the example we have. Okay, so you can see we have 3 lanes in the north-south direction, sorry, east-west direction, 2 lanes in the north-south direction, and you can see that how they are divided, and for each direction the flow is given here. Okay, so we start first with the left turning. Okay, so for left turning, if you are doing the left turning for east-west, okay, you can see that for east-west I have two opposing lanes. Okay, so if I'm looking from this side, I have 2 opposing lanes. If I'm looking from this side, I have 2 opposing lanes. The left turning lane is not counted as opposing lane. This lane is not counted as opposing lane, this one and this one. Okay, because left turnings can happen without or with these lanes together, no problem. 2 left turns can happen at the same time. Okay, so we will not count this as an opposing lane. If you look at north south, I have 1 opposing lane again, because this one and this one is for left turning. Okay, so north south 1 opposing lane, and east west 2 opposing lanes. What we do is we multiply the straight, okay, with the opposing volume, this one. Oh, sorry, not straight. We multiply the left turning with the opposing volume, so this one. Okay, so 300 by 550 plus 50 is 600, and then we do it for the other side, 200 into 950. Okay, so let us do that first. So we have westbound, 300 multiplied by 600. How much is that? Then for eastbound, left turning is sorry, this is what we call as eastbound, what we call as westbound. Okay, westbound means going towards west, so 200 is going towards, like, facing west, right? So 200 here and 950 on the other side. Similarly, facing north, so northbound, left turning 150, multiply by the opposing, which is 350 and 150. So it's 350 plus 150 is 500. Southbound, so facing down, left turning is 150. Okay, and then we have this one, 350. Okay. How much is this? Yes, how many are, how much are these values? Okay, so for 2 lane, if you have 2 opposing lanes, east west, then our yeah, for two opposing lane our limit is 90,000. So if east west goes more than 90,000, we will have a separate left turning phase. And for north south, one opposing lane, so the limit is 50,000. So if you cross 50,000, then we will have a separate phase for left turning in the north south direction. Now in our case, this goes more than 90,000 and both of these go more than 50,000. Okay, so that means what? All phases or all directions will have separate left turning phases. Okay, so left turning will be protected. So the first step is done. The second step is identification of lane groups. Okay, now east west lane movements are same, north south lane movements are same. So tell me how many lane groups in east west and how many lane groups in north south. Okay, in east west you have two lanes, right? So you can have one lane group or two lane groups. In east west you have three lanes. Okay, so you can have one lane group, two lane groups, or three lane groups. Okay, so which of these we have? In the north south, do we have one lane group or two lane group? Two lane groups. Should I put each lane in a separate group or can I group them together for the north south? Yes, tell me. Two groups, yes, we have to put them separately because they have different movements. You cannot put them in one group. What about the east-west? How many groups should I have for the east-west? 1, 2, or 3? Two. Yes, who else is with Ali? Should I have two lane groups for east-west? Yes, Zainab Ali, Zainab Abdul Azim. What do you think? East-west should have two or three? Three, yeah. Okay, east-west would have three because you see all these lanes have something different in them. None of them is exactly the same. Okay, so you can only put those lanes in one group which are exactly same. So there is no exact similarity here. Okay, yes, there is a common movement here, but then this one has a different one as well added. So we cannot put them together. So lane groups we have 2 north south, 3 east west. Okay, then comes so we identified the lane movements. Another thing which I should have mentioned, we check the volume, but the main street, this street has more than 45 miles per hour speed. So this one, this is another indication that this street should have protected left turn, separate left hand phase. Okay. So even if the volume was less, because of the speed I would have provided effective left hand phase. Now all these values are volumes, all of them are volumes. Okay, I need to convert them into flow rate of passenger cars per hour. Okay, I need to convert them into flow rate of passenger cars per hour. Okay, to convert volume to flow rate, I'll divide all these values by 0.95 peak hour factor. So all these values must be divided by 0.95, which is the peak hour factor. Okay, this will convert it to volume. To convert these values to passenger cars, they are vehicles per hour right now. To convert them into passenger cars, I have to do this, and we did it in the previous chapter as well. So if you want flow rate in passenger car, so I'm doing it for example for this one 900. Okay, so 900 divided by 0.95, which is the peak hour factor, multiplied by FHV. factor for heavy vehicle. Okay, and factor for heavy vehicle comes from here. We have used it in the previous chapter. Percentage of it was percentage of trucks, equivalency factor for the trucks -1. Okay, and this. Now percentage of trucks is given 0. Okay, so this whole thing becomes 0. So you have 1 upon 1. So this factor is 1. Okay, why? Because P T equals to 0. Okay, so this factor becomes 1. Okay, so what does it mean here? It means that this is equal to 900 divided by 0.95. What happened? 900 divided by 0.95. Okay, I did something, I don't know what I do. Okay, back to normal. Okay. Okay, any confusion, any problem here? I'm converting the given volumes to flow rate in passenger cars per hour. To do that, I must divide by peak hour factor, which is given, and by a factor of heavy vehicles. Factor of heavy vehicles is calculated like this. Okay, and then in the question, the percentage of trucks is given as 0. So this becomes 0 and the factor becomes 1. Okay, so just to convert it to flow rate in passenger cars per hour, just divide by peak hour factor, because FHV is 1. Is this clear? Okay, I'll take it as a yes. So this is what they have done. So this is my passenger cars per hour flow rate. Okay. Now the next thing we do is the saturation flow rate. Okay. In this question it is given, but in the previous lectures we have seen how we can calculate it using the adjustment factors. So there is always a base value which is given. You can see 1700, 1900, 1800. These are basically base values. So they have not applied any adjustment factor, then they have just taken the base value. But whatever it is, we were not required to calculate them. Okay, we were not required to calculate them. Okay, so saturation flow rate in this question did not require any calculations because they have taken the base value. Now, if I go back to the lanes, I have 900 straight eastbound. 900 straight eastbound. This some of this 900 will go from lane 2 and some of it will go from lane 3. Okay, this 900 will be divided, right? There is only one lane for left turning, so this whole 300 will go from this lane. There is only one lane from which right turning is allowed, so this 50 will go from this lane, but I need to divide the 900. Okay, now there are different ways to divide the flow. We can divide it equally. Okay, but we know rail traffic is not like this. Drivers do not go in different lanes in equal numbers. Okay, they always prefer one lane over the other. Okay, so if you are driving on this road going towards east and you are going straight, which lane you will prefer more out of these two? The middle one or the right one? Which one you will prefer more? The middle lane or the right lane? The middle, right? So middle will have more or should have more volume. Okay, so 900 should not be divided equally. As per the driver's mindset, the more part of 900 should go in the middle lane and less part of it should go in the right lane. So this is what they have done. Okay, I will just give you an example. So for example, I want to calculate the flow in the 3 lanes of eastbound. The flow in the 3 lanes of eastbound. Okay, these 3 lanes which are facing east. The first lane is a left turning lane. So its flow, I'll call it EB1. Its flow is a left turning flow. Okay, or I can, okay, I'm just doing it here. You can see the values on the next page. Then I have the middle lane. Okay, So I call it eastbound 2, and now I have to divide 900. Okay, let's say 55% of the drivers will go in the middle lane. The remaining will be 45%, right? So they will go in the, oh sorry, not this, multiply. Okay, 0.95 is the peak hour factor. So I'm saying 55% of 900 will go in the middle lane. The remaining, the lesser number will go in the right lane. Okay, and then 900, the remaining of 900. Okay, plus the right turning. The right turning is 50. Again, divide by peak hour factor. So this is how the flow in the 3 lanes of eastbound is calculated. Okay. If the heavy vehicle factor was not 1, I would have put that as well here. Okay. So this is how these values are calculated. Where is it? These 3 values. This is the left turning divided by peak hour factor. This is portion of 900 divided by peak hour factor. This is the remaining portion of 900 plus the right turning divided by peak hour factor. Okay, so these are how these values, and the same thing will be repeated for westbound as well. Okay, now this 0.55 is taken in this question. Okay, it depends upon driver behavior, but as far as the question is concerned, this must be given. As far as the question is concerned, this must be given. Now go towards, if I go towards north-south, it's easier because left turning is only from one lane and the right hand straight is only from one lane. Okay, so the whole left turning is in southbound 1. Where is the left turning for southbound? This one. So the 158 is for SB1. Okay, SB2 will be 389, which is through straight, plus the right turning, the whole of it. No division here. Okay, so 389 plus 53 gives you 442, which is the second lane of southbound. Okay, is this clear? Any questions here? Any problems? Okay, thank you. So you have the flow rates, you have the saturation flow rate. Now you will take the ratio of these two things for every lane group. So we have 3 lane groups for east and west, 2 lane groups in north and south. So you see for each one of them, they have taken V by S ratio. So V is from the given volumes after converting it to flow rate and dividing and whatnot. So this is for each lane group now, and divided by saturation flow rate of each lane group. Okay, so this is why we are putting same lanes in one group, because the saturation flow rate for those lanes will be the same. Okay, so this is what we have for each lane group. Then we move on. Now we will move on to the phasing plan now. Okay, and phasing plan and the rest of the process will depend upon the V by S ratios. So just keep it in mind. We calculated V by S ratios on this in this step. Okay, so this shows V by S ratio for each and every lane. Okay, and this is the first phasing plan. It's very simple. All movement from one direction get the same time. Okay, so all from eastbound, all from westbound. Okay, and all from northbound, all from southbound. Okay, but you know that each one of them has lane groups, and each lane group has a separate ratio, V by S ratio. So this one, we said left turning needs a separate phase, right, protected. So this one, the left turning lane had a V by S ratio of 0.19. This lane has a V by S ratio of 0.19. Then we have these 2 lanes in the other phase, because both of them are straight. So both of them have to be in the same phase. I cannot let 2 lanes with a straight movement in different phases, right? So they have the same phase. So now this one, both of them are 0.27. So the critical V bias ratio is 0.27. If I look at this one, same thing. Okay, left turning 0.12, and out of these two, I have 0.17, which is the critical one. Okay, then I move on to the next one, which is northbound, 0.09, 0.19 together, and then this one, 0.23 and 0.09. Okay, now all of them, or sorry, a pair of them is happening simultaneously. So this pair is simultaneous, this one simultaneous, this one and this one. Okay, so when movements are happening simultaneously, you don't need to take V bias ratio for both simultaneous movements, both parallel movements. You can take the most critical one. So if I look at the first phase, the critical V bias ratio is 0.27, the greater one. Higher V bias ratio means higher flow. So the flow which is higher, it becomes more critical. Okay, so this one is more critical here, 0.27. This one is more critical here, 0.17. Out of these two, 0.19. Out of these two, 0.23. So if I do the summation of V bias ratios from this thing, I get 0.27, 0.17, 0.19, 0.23. Okay, and they come out to be 0.86. Now if V bias ratio is less than 1, we are in the safe zone. Okay, but if V bias ratio is very close to 0.9, then we may have a problem. Okay, or let me rephrase it. If V bias ratio is more than 0.85, we can have a problem later on. Okay, so I should try to keep the V bias ratio as low as possible. Okay, and definitely lower than 0.85. Now right now it is 0.86, so I may have a problem later on. So let us see if we can bring it down further. Can I rearrange the phases to bring down the V bias ratio further down? Okay, right now I have paired the movements according to the direction. Okay, what if I pair the movement according to or I pair the movement from different directions together? Okay, so right now I am pairing 0.19 with 0.27 and 0.17 with 0.12. Okay, if I pair 0.12 with 0.19, they are not conflicting, they are going in different directions. Okay, so they can be paired, and the difference between 0.19 and 0.27 is higher than 0.19 and 0.12. Okay, so this is another indication that your pairing is becoming better. The movements which you are pairing, if the difference between their V bias ratio is less, then you will have a better plan, a better phasing plan. Okay, so right now in this phasing plan, the difference between them is 0.08. If I do this pairing, 0.19 and 0.12, the difference between them will be 0.07. Okay, so difference is decreasing. The difference between the pairs is decreasing. The simultaneous pairs, the parallel pairs, is decreasing. That means it's a better plan. Okay, so this is what they have done here. From here to here, this is what they have done. So instead of grouping movements of the same direction together, they are grouping them from opposite directions together. So these two left turnings group together and these two straight groups together. Same thing in the north south as well. Okay, so this was the most obvious one, and then this is more complicated one. Okay, and again I will pick the critical V bias ratio from the parallel movement. So 0.19, 0.27, 0.09 and 0.23. Now if I add these together, 19, 27, 9 and 23, I get 0.78. Okay, so it was 0.86. When I flipped it, it became 0.78. So it became better, right? So if it was 0.86 here and then it became 0.9 here, that means it is becoming worse. Okay, so you can try different plans, and whichever gives you lower V bias ratio, this is your indication that this plan is better. Okay, so our idea is to minimize the V bias ratio. Okay, when I went from here to here, V bias ratio minimized. Okay, now can I make it further better? I can stop here. It is less than 0.85. I can stop here. But in this question, they have done another trial. You may do it, you may not do it. Okay, but we need to check different options basically. Okay, now if you look here, okay, we have this movement and this movement. They are for the same direction. Okay, this movement needs more time, this movement needs less time. This and this can happen together. This left turning and this straight can happen together. Okay, but this one is paired with a movement which needs less time. Okay, so that means what? When I'm giving time for this one, I'm giving extra time to this one, but this time is wasted for this movement. Okay, this movement doesn't need the same amount of time as this one. So can I extend this? Can I reduce the time of this movement? Now you see this one is non-critical, 0.19, 0.12. So 0.12 needs less time actually. It doesn't need the same amount of time as 0.19. So I can reduce this one and I can extend this one into this. This is what they have done here. They have reduced the time of non-critical movement and they have extended the time of the critical movement of the next phase. Okay, so they are happening one after another because they are conflicting. This is straight and this left turning is conflicting, so they have to happen after one another. Okay, but this one and this one can happen simultaneously, and this one can happen simultaneously. So I'm giving more time to the movement which needs more time. Okay, and I'm compressing the time of the conflicting movement which needs less time. If this one was critical, if this one was 0.9 and this one was 0.12, I cannot do this. Then I will see if I can extend this one or not. Okay, but in this case I can extend this one. Okay, because this one was non-critical. So I did this. Okay, and this one there, no change. You can see here, no change, because there is no such situation here. Okay, both of them need the same amount of time. If the same situation was here, this one was 0.09, this one was 0.05, I can see if I can extend the other one or not. Okay, but here I cannot because both of them have same V bias ratio. Okay, once I have extended it, now pay attention how summation is calculated. Pay attention to that. Now these ones, this is one pair, one sequence of movements, 0.19 plus 0.17. If I do 0.19 plus 0.17, how much I get? How much is this? .36. Okay, and if I do this 0.12 plus 0.27, I get 0.39. Okay, so as we have been doing, 0.39 is more critical than 0.36. Okay, the higher one is more critical, right? The higher one is more critical. So this sequence becomes the critical one. Okay, earlier movements were completely parallel. So I can pick 0.19 from here, 0.27 from here, and so on, because they were parallel. But here some movements are overlapping. Okay, so from 0.12 and 0.19, can I pick one? No, because 0.19 is overlapping. Okay, from 0.17 and 0.27, can I pick one? No, because 0.27 is overlapping. So when you have overlapping movements, then you look at the sequence. This sequence gives me 0.36. this sequence gives me 0.39. So this sequence is more critical. Okay, so when you have overlapping movements, sequence shows you which the sequence becomes critical, not movements. Okay, on this side I still do the same. This one is this one, same, any movement can be critical. This one and this one, which one is critical? 0.23. It's very clear, no overlapping here. Okay, so this side is without overlapping. You can pick one movement exactly for the submission. Here you cannot pick one movement because of the overlapping. You have to pick a sequence. Okay, so when I pick this sequence 0.39 from here, 0.12 plus 0.27, 0.39 critical sequence from here, 0.09 from here plus 0.23 from here, the critical one. Okay, now the summation is 0.71. Okay, so which is obviously better than 0.78. Okay, so if you try different versions of phasing plan and your V by S ratio is decreasing, then the previous trial will be discarded. You will go with the new trial. Okay, so I went from here to here, my V by S ratio decreased, so this one is discarded. Then I went from number 2 to number 3, V by S ratio further decreased, so I will cancel number 2, I will go with number 3 now. Okay, can we do something else with this one? Maybe we can do, maybe. Okay, they can be, so you have to use your imagination here. Okay, but these 3 steps basically tell you the basics of how we develop the phasing plan. Okay, we try different sequences, we see if we can do some overlapping, and then our target is what? The lowest V by S ratio. Okay, the lowest V by S ratios. Okay, so this is what we have. Okay, so the final value of V by S ratio is 0.71 in the end. Is there any confusion here? V by S ratios and the phasing plan don't have an equation that you can remember. So you have to rely on your understanding. So did you understand what I have presented just now with the phasing plan? Okay, thank you. Moving on. So now we can calculate yellow and all right time. Okay, yellow and all right time. This equation. The first 2 terms yellow, last term all red. I need speed for each road. I need a standard deceleration given here somewhere. See 11.2, A is given. I need the gradient of the road. It is level terrain, so gradient is 0. I need the gravity. I know the gravity. And then I need perception reaction time. Perception reaction time normally for stopping side distance is 2.5 seconds. You have used it in highway engineering course as well as in traffic engineering course. Perception reaction time. What else do we need? We need L, which is the length of the car. A standard car has a length of 20 feet. Standard car has a length of 20 feet. So in this equation, TPR is standard, A is standard, small g is standard, capital G is 0 because of level terrain, and S is given. Okay, for this one it is 45. For the other one, is it written here? It should be written somewhere. You can check in the book. Okay, but for example, if I want to calculate it for east-west direction, okay, I may have forgotten to put the speed for the north-south direction. You can check it in the book, it's given here, but I will tell you how the east-west is calculated. So I want to calculate the capital Y, which is the clearance interval, sorry. Okay, so TPR 2.5, S naught, which is 45, Okay, then we have this. Now S naught must be converted to feet per second. One 1.47. There is a conversion factor. Okay, this equation doesn't have a conversion factor. 2 multiply A, which is 11.2 standard. Because gradient is 0, this becomes 0. Okay, this is my yellow time. Okay, and then this is my all red time. Now here I know L is standard card length 20. I know S naught, which is 45 into the conversion factor. Then W is the width crossing in this direction. Okay, so if I go here, now you see here, if I'm crossing east-west, I have how many lanes here? 1, 2, 3 lanes. Each lane is 12 feet. Each lane is 12 feet. So for the width, I have W 12 into 3 plus I have a median. I have a median. Median is how much? 5 feet. Okay. So this will be how much? 41 feet. So this will be 41 plus 20, W plus L divided by 45 conversion factor. This will give you the clearance interval for the east-west direction. Okay, and then you can separate the first two terms for yellow, calculate this separately as yellow and this one separately as all red. Okay, so this is what they have done here. If you are calculating width for north-south, okay, so north-south W, I have how many lanes? 1, 2, 3 here and 2 here, 5 lanes. So 12 into 5 plus the median. So it will be 65 feet. Okay, so this is how the W is calculated. So W will change according to the geometry of the intersection. The speed is the speed of the road, and the rest of the things are standard except capital G, which is the gradient. Okay, so this is how these values are calculated. So this is the first two terms, this plus this. Okay, it is giving you 3.96. okay, and this one is 0.92. So all red is 0.92 and this one is 3.96. So obviously we will round it up. So yellow is 3.96 goes to 4 and 0.92 goes to 1, and the same thing for the other direction. So this is your yellow. 1 plus 1.96 means 2.96. So round it up to 3, and then 1.93 rounded up to 2. Okay, so these are your yellow and all red times. Okay, for the lost times I explained it previously, and lost times, then you have to go in the field and you have to see how much is the lost time. Okay, so it comes from field observations. Okay, so L1 was startup lost time, L2 is clearance lost time. Okay, L1 is the first 3-4 vehicles which are going slower, the extra head wave between them, and L2 was when the signal is just about to close, it is yellow, so the vehicles stop entering till the next green is the clearance lost time. Okay, so these two values, you obviously you have to go in the field and you have to see how much time the drivers are taking, but in this case they are assuming it to be 2 seconds. Each one of them is 2 seconds. It's assumed. Okay, 2 seconds is a reasonable assumption. You will find it in the other books as well. Okay, that they take the lost times between around 2 seconds. Okay, some of them are giving a range between 1 and 2 seconds. Some of them are saying between 2 and 3 seconds, 1 and 3 seconds. So 2 is a reasonable value for both of them. So each lost time is 2 seconds, 2 seconds. Total will be 4 seconds. Okay, each one of them is 2 seconds. So total of both of them is 4 seconds. Okay, 4 seconds in each phase. How many phases we have? Again, you don't need to count the parallel phases twice. These two are parallel, these two are parallel. I will not count this one and this one, both of them. No, I will just count one of them. So this one, 4 seconds here, 4 seconds here, 4 seconds here, and 4 seconds here. Okay, so 4 plus 4 plus 4 plus 4, 16. Okay, so my total lost time is 16. Then target V by C ratio. This is target V by C ratio. We have to select it. It has a range. It should not be more than 0.95, and it can be between 0.85 and 0.95. Okay, it should not be more than 0.95. In some cases, you may take it to be even 0.8 as well. Okay, but in most of the cases, the range is 0.85 and 0.95. So we are targeting V by C ratio of 0.9. What does it mean? V means your demand, C is the capacity. V by C ratio is 0.9. That means capacity is 10% higher than the demand. So this is my factor of safety. Okay, I mentioned it last time as well. So now you have this. I can calculate the cycle length. For cycle length, I have two equations. Okay, XC 0.9, we just did it. L is total lost time. Remember, 4 seconds for each phase, and we have 4 phases, so 16. And this one comes from the phasing plan. It was 0.71 for the final phasing plan. Okay, we have two equations for cycle length. This one is more common. Okay, and this one is an old empirical equation. We call it the Webster's equation. Okay, so if I'm using this one, C1 equals 16 seconds of lost time, target V by C ratio 0.9, then 0.9 again minus 0.71. So this will give you cycle length, first cycle length, second one will be 1.5 into 16, the lost time, plus 5. This is, now you can see there are many constants here. 1.5 the constant, 5 the constant. From where is it coming? We don't know. Okay, so this is why this equation is empirical. Okay, so you can have these two values of cycle length from here. Okay, and if you are using this equation, now you see here, if you are using this equation, okay, your target V by C ratio minus the V by summation of V by S ratio. So this is why I said, if this ratio is close to 0.9, you may have a problem here. Okay, because this value can become very, very low. So if I'm doing 0.9 minus 0.89, then you will get a value 0.01. You divide by 0.01, this value will become very high. Okay, so we want to keep this ratio as low as possible. Okay, so that's why we keep the summation V by S less than 0.85. So you don't have any problem with your target V by C ratio. See, they are subtracting, right? So I want to keep this summation as far from this one as possible, so that the whole value is not shooting up. Okay. If you have, for example, your summation V by S ratio is, let's say, 0.92, then this value will become negative. 0.9 minus 0.92 will become negative. So this equation then becomes useless. I cannot use this equation. Okay, so this is why summation of V by S ratio has to be as low as possible. Okay, can you give me these values? Yes, anyone? What are these values? Okay, so C2, now you can see C2 is a very rounded figure. I don't need to do any rounding off here. but there are some rules given for rounding off. If you have to do rounding off, there are some rules given. Okay, so if you get a value which is more than 80 seconds, then we round it off to the nearest 5 seconds. If you get a value which is less than 80 seconds, we round it off to the nearest 10 seconds. Round it up, okay, not round off, round up. Okay, so in this case, we have 75.79. Okay, so what we will do, it is less than 80 seconds, right? C1 is less than 80 seconds. So should I round it off to 80 or 85? According to this rule, this 75 point something should be rounded off to 80 or 85. Tell me. So C2 has no problem, right? C2 is already 100, exactly 100. What about C1? C1, should I round it off to 80 or 85? 80. Okay. So round it off to 80 seconds. Okay, because when you round it off, you get 80. Okay, if it was less than 80, we round it off to the nearest 10 seconds to be you know, clear with you. Okay, so if this value was, let's say, 68. Okay, so I will look at the nearest 10 seconds then. Okay. Anyways, so moving on, now we have two cycle lengths. We will use both of them. In this question, they are using both of them for the rest of the calculations. Okay, from the cycle length. So my cycle length is now 80 and 100. 80 and 100. Forget about the actual value. Now we have 80 and 100. Now the signal has a lost time of 16 seconds total. Cycle length minus lost time gives you total effective green. Cycle length minus lost time gives you total effective green. So with cycle length minus 1, cycle length 1, I'll do 80 minus 16. With cycle length 2, I will do 100 minus 16. Okay, so total effective green with cycle length 1, 64. 80 minus 16. With cycle length 2, 100 minus 16 gives you 84. So this is my total effective green time. Okay, total effective green time. Now I will divide this total effective green time into different phases. Going back to here, now you remember these are my phases. I have these V by S ratios, and the total effective green time should be divided according to these ratios. Summation of these ratios is 0.71, remember. Okay, so you need to remember V by S ratios and the phases, movements, and the total of them. Okay, so for example, I want to calculate the effective, or I want to allocate the effective green time for this movement. This movement has a V by S ratio of 0.19. Okay, total effective green time 64 or 84, one of them, any one of them. 64, let's say. Okay, so it will be 64 multiplied by V by S ratio of this movement divided by the total V by S ratio. Okay, this is for this movement. If I am doing it for this movement, it will be 0.12. Okay, multiply by this 64 and divide by 0.71. Okay, so this is what they have done here. And for our convenience, they have written the movement exactly here. Okay, so for 0.19, when I was using 64 seconds of effective green, I got this much. And when I was using 84 seconds of effective green, I got this much. So 22.5 is, how do I get 22.5? 84.19 V by S of this movement divided by 0.71 total V by S. Okay, this I got 22.5. Okay, so for all these values I do the same thing with all these values. Now some of these values are parallel. Okay, so I don't need a green time for this one and then another one for this. They are overlapping, they are parallel, right? Okay, so I need one green time, not both. Same thing here as well. I don't need a green time for this one and this one separate. No, they are together. Okay, so together means what? Green time for this one and this one will be equal. Okay, and this is north south through, right? North south through. They are having the same green time. Now if I calculate using V bias ratio of this one, I will get a higher number. If I calculate using 0.19, I will get a lower number. Okay, which one will I take? I will take the higher one, obviously. Okay, so I got two values here, one for southbound, one for northbound. You can see it here. Southbound through, northbound through. Okay, I got 20.7 here, I got 17.1 here, but according to my phasing plan they are parallel. So I don't need 20.7 and 17.1, I just need 20.7. Okay, so both of them become 20.7. According to this cycle length, 27.2 here and 22.5 here. Okay, but they are parallel, so it will become 27.2. Okay, so eventually you will have to see, you will do it for all the movements, but then you will see, go back to your phasing plan and see which one is critical, and you will make them, which one are parallel, and you make them equal. Equal means you will take the higher value of the two. So for the two parallel movements, I will take the higher value. Now, what will happen to this side? Now this side, I cannot say 0.12 and 0.19 are parallel. They are not completely parallel because 0.119 is overlapping with another movement as well. Same thing here as well. So as I told you earlier, we'll take the sequence. Okay, so I will take green time of this one plus this one and compare it with green time of this one plus this one. Obviously this one will be higher. This summation of green time will be higher. So this is westbound left plus eastbound through. Westbound left, eastbound through. 10.8, 24.3. If I take the other combination, 17.1, 15.3, this is lower. Okay, so I'll take this one. Now if I take this one, I get an answer 35.2. 10.8 plus 24.3. Answer is 35.2. If I add these two, the other sequence, I get 17.1 plus 15.3, which is 32.4. Now they are parallel. The sequence is parallel. The sequence is parallel. Okay. So when 35.2 happens, I don't need 32.4 again. So I make the sequence again. I make the sequence same. Okay, so I have a difference of 2.8 seconds here. I need to add 2.8 seconds in one of these two movements. So whenever we have this sort of a problem, we always increase the through movement. So this 2.8 will be added to the through movement, westbound through. Okay, I could have added it here as well if I feel the volume is higher, but we will add it here. So this becomes 18 seconds. It was according to its own V by S ratio 15.3 seconds. But you added the difference of the parallel movement to it, it became 18 seconds here. Same thing here. Okay, you do summation of this and summation of this. This one will be higher. How much was it higher? This much, 3.6 seconds higher. So I will add this 3.6 seconds to one of these two movements. Which one? Normally you prefer the through movement, the straight movement. Okay, going back. So this one, according to the first cycle length, required 35 point something seconds. This one required 32 point something seconds. Okay, but I know according to my phasing plan, there is no 32 and 35. They are at the same time. So when this 35 completes, this will also finish 35 seconds at the same time. So where should I add the difference in these movements? Which movement should have the extra time? they have given the extra time to the through movement. Okay, is this clear? Is this point clear? Any questions? Okay, I will suggest that you go through the video later on. Okay, and see if you have any questions, because we will now continue next Monday, right? So just check in the meanwhile that everything is clear or not. Okay, this is my suggestion.